Welcome to this video on A-level maths mechanics, modelling in mechanics. Since this is the first mechanics video, I'd like to start by discussing what mechanics is. Mechanics is the branch of mathematics that deals with motion of objects and the forces placed upon them. How does mathematical modelling apply to mechanics? Firstly, you need to understand what is the problem. Then you look at what assumptions can be applied. In order to make an assumption, you generally have to make some simplification. Once you've done that, you can then look at the entire simplified problem and then calculate and predict results. Simply put, modelling is making a simplified representation of a problem and using it to calculate and predict answers. We can use mathematical models to simulate real-life situations. By adding specific conditions, this allows us to simplify the model and help interpret the model in a timely manner. In the next couple of slides, let's see how we apply common assumptions in mathematical modelling. It should come as no surprise that this branch of mathematics mechanics has its own language and terminology. When we talk about certain items in mechanics, it is important to understand what modelling assumptions are applied to that object. First of all, let's look at a particle. It is an object with mass, but no size or dimensions. Its mass is concentrated at a single point. The rotational forces are negligible, and the air resistance upon it is negligible. A rod, pole, beam or wire is a one-dimensional object. Its mass is concentrated along the line of the object. It doesn't have any thickness. It is rigid and does not bend. Here we have two people carrying a sheet of glass. A sheet of glass is a good example of a lamina. It is a two-dimensional object that has an area but no thickness, and the mass of the lamina is distributed across the surface of the lamina. A uniform body has its mass evenly distributed throughout the object. The word uniform means constant. A uniform body has its centre of mass at the geometric centre of the object. A light object is an object whose mass can be considered negligible because its mass is so much smaller than all of the other masses in the system. A great example is in this crane lifting up the pallet of bricks. It's using, and I've highlighted here in orange, a chain. It's using a chain to lift up the pallet of bricks. The chain is much lighter in mass compared to the bricks and the thing that's holding the bricks and the crane itself. So because the mass of the chain is so much smaller, we can say that the mass of the chain in this instance is negligible. The chain is a light object. An inextensible string is one that does not stretch, meaning that if particles are connected, they will accelerate with equal amounts. In this example of the lady holding herself up on a platform by a string over a pulley, she will pull, in order to move upwards, she will need to pull her arms downwards. So in this instance, if the string is inextensible, the amount with which she accelerates her arm downwards, that will be equal to the amount at which she accelerates upwards. Smooth surfaces have no friction. Rough surfaces have friction. Pulleys are assumed to be light and smooth. We assume a pulley is light because its mass is considered negligible compared to the rest of the mechanical system, i.e. the mass of the girl and the mass of the platform is much heavier than the mass of the pulley. A pulley also has very little friction in it. We assume it has no friction in it. We say the pulley is smooth. And what this means is that the tension on either side of the pulley is equal. So in the case of the girl on the platform, the tension in the string keeping the platform upheld, that's supporting the weight of the girl, that is the same as the tension in the string on the right side that the girl is pulling down. And this is because there is no friction in the pulley. A bead is a particle with a hole in it, such that it can be threaded through a wire or a string. It will move freely along the string without any friction. Therefore, the tension of the wire or the string either side of the bead is equal. So in the diagram, what we have here is we have a chain, and the bead I've highlighted in red is a link that links the chain to the diamond heart-shaped padlock. So it's the red link that is the bead in this example, and because the bead is frictionless, it means that the tension of the chain either side of the bead will be equal. A peg is a support from which an object can be suspended or rested upon. The peg is always in a fixed position. Air resistance is a force that acts in the opposite direction to motion. So, for example, this parachutist has his weight pulling him down towards the earth. So the air resistance is acting in the opposite direction, upwards. In most maths mechanics problems, we exclude air resistance for simplicity. Gravity is a force that acts between objects that have mass. In maths mechanics, we assume that the gravity is caused by an attraction of an object towards the Earth. The value we assume for gravity is 9.8 meters per second squared. We always say it acts uniformly and it always acts vertically downwards. Hence you can see in the diagram a field with the lines of gravitational force acting downwards and equally spaced, showing their uniformity. Well, this has ended up being quite a long video, so I think it's best that we take a break and we'll call this the end of part 1. So thanks for watching the end of part 1 of this video. Part 2 will follow shortly.